Let's take a quick look at how the 100% POI, or probability of intercept, is calculated on a real-time spectrum analyzer. Regal's RSA 5000 has a 100% POI on pulses as short as 7.45 microseconds. But how do we know that? Let's see. A real-time spectrum analyzer uses FFTs, or fast Fourier transforms, to simultaneously measure power across the span. The RSA 5 calculates its FFT every 6.83 microseconds. Each of those FFTs has a 1,024 points. With a 40 meg span, the sample rate is 51.2 megasamples per second. So each sample is 20 nanoseconds, which means that the full FFT takes 20.48 microseconds. There's also an RBW setting, which effectively is a window size. For POI, the most important one is the smallest window. In this case, that's RBW 6, which is a 32-point window. 32 points at 20 nanoseconds lasts just 640 nanoseconds. Looking that together, we can see that with an RBW1 or RBW2 window size, the measurements are gapless. Every point is used in one of the FFTs. With RBW6, there are some gaps, but the smallest window means that the smallest pulse width can be accurately captured in power. So let's look at a couple examples using RBW6. Here's a 2.77 microsecond example. With these short pulses below the POI, 100% POI value, we see that sometimes the pulses are missed entirely between the two FFTs. We've zoomed in the time domain here, and we see the FFT capture first in blue, and then the second capture is in red. Some of those pulses are captured accurately, but some of them are missed entirely. A 2.77 microsecond event has about a 50% chance of being accurately captured. Here we can look at a short video. With RBW1 setting, you see every measurement or see every pulse event, but the power is low. When we switch to RBW6, we miss about half of the pulses entirely, but we have a better chance of capturing the amplitude accurately because of the shorter window. Now let's look at the 7.45 microsecond event. This is actually the POI value. And that's because the POI value is always the time between the FFTs plus one sample less than the window width for the current setting. On this 40 meg span, that's the 6.83 microsecond time between FFTs plus the 640 nanosecond window minus 20 nanoseconds. So that's 7.45 microseconds. And you can see that visually in the first blue pulse event line. That shows the pulse event starting right when the FFT1 begins capturing. So it's accurately measured in FFT1. And it stops just short of the end of FFT2. So that's the minimum event. Any shorter than this, and it could fall in between and miss both FFTs accurately. And any longer than this will always be measured accurately by at least one of the FFTs. So that's how we define the POI, as the shortest time that's guaranteed to be measured accurately by one of the FFTs. Here's a video demonstrating that. Again, with RBW1, we never miss a pulse. They're once per second. But sometimes the power is low because the window does not totally overlap with the pulse. Now we move to RBW6, and here we find that every pulse is captured. Sometimes the pulse overlaps two FFTs and we get a double event, but one of them, the higher one, is always accurate. So that's how you look at a POI, or 100% probability of intercept, on a real-time spectrum analyzer, and what it means.